If we know the mean and standard deviation for a normally distributed random variable, we can compute probabilities. And if we know a probability in the mean, we can find the standard deviation. Likewise, if we know a probability in the standard deviation, we can find the mean. But what if we only know probabilities? For example, suppose a company's annual profit has a normal distribution with a variance equal to the cube of the mean. The probability of an annual loss is 5%. Let's find the expected annual profit. So if x is the annual profit, we know the probability that x is less than 0 is 0.05. Since this probability is less than 0.5, the corresponding z-score must be negative. So let's designate it minus z prime. And so our probability that we're less than 0, well, that's the same as the probability we're less than some negative number. By symmetry, that's the same as the probability we're greater than the positive version of the number. And that's complementary to the probability that we're less than or equal to it. And so our probability of interest is 0.95, and that tells us z prime, the positive number, is 1.64, and so the corresponding z-score is negative 1.64. Now, since the variance is the cube of the mean, and the standard deviation is the square root of the variance, that gives us. And so converting from our z-score, negative 1.64 is x equals 0, and so that gives us which tells us the mean. Or let's suppose the quarterly profit is normally distributed and the probability that the company earns a profit is 0.8. If each quarter's profit is independent with the same distribution, find the probability the company earns a profit during the year, that's 4 quarters. So if xn is the quarterly profit, let it have mean mu n and standard deviation sigma n. So remember, means and variances add, so the annual profit will have mean and variance, so the standard deviation will be. Since the probability is 0.8, which is greater than 0.5, then x1 must be less than the mean. So we'll let the corresponding z-score be designated negative z prime, so we don't have to mess around with negatives in our values. And that tells us the probability is z greater than or equal to some negative z prime, which by symmetry is the probability that we're less than or equal to some positive z prime. And so we find that z prime is 0.84. So x1 equals 0 corresponds to z equals negative 0.84. And we can substitute these into our formula for the z-score, and we find a relationship between the mean and standard deviation. But how do we find the mean and standard deviation separately? At this point, we'll invoke an important rule in life: procrastinate. Sometimes we don't need to solve a problem. The problem will take care of itself. So we don't need to solve the problem of global climate change. The problem will solve itself, though we might not like the solution. Anyway, for our particular normal random variable, we have the mean. And for a positive profit, we want the probability that x is greater than or equal to 0. And so we can find our z-score, and note that our standard deviation will factor out. And that probability that we're greater than a negative is the same as the probability we're less than the positive, and we get that by the table. Now, because there are two unknowns, mean and standard deviation, we might need to probabilities. So let's say we know the 60th percentile and the 80th percentile, and then we can try and find the 95th percentile. So the percentiles tell us two probabilities. Now, note that because these are less than probabilities and they're both greater than 0.5, that means they're both greater than the mean. And we find the corresponding z-scores. Now, the closest z-scores to the given values are 0.25 and 0.84. And so x equals 1,000 corresponds to 0.25, and 2,000 corresponds to 0.84. Substituting these in give us so the mean and standard deviation solve a system of equations which we can solve. Now let C be the 95th percentile. We want the probability that Z less than C is 0.95, and we find the corresponding z-score is 1.645. Converting this back from our z-score gives us and so that's about 3,400 if we round to the nearest hundred. Or suppose our losses follow a normal distribution with mean and standard deviations, and the pth percentile of losses covered by the first policy is the 81st percentile covered by the second. So first, we find that the 81st percentile of the policy corresponds to a z-score of 0.88, and we can convert that into a loss value that depends on k. Now, in the first policy, the same value has a different mean and standard deviation, and so it'll have a different z-score, which will be, and we find that our probability is, which would place us in the 91st percentile.